Hello all. Today let me start our session with the Unit 2 Gate Level Minimization. And in that gate level minimization, the first topic is map method. So in our last unit, we have discussed about how to minimize your function using Boolean algebra, as well as we are going to use the laws and theorems of Boolean algebra, and we derived your function into minimal expression. So now if you use that procedure of using algebraic procedures, so it is very difficult to apply that in a systematic way, as well as it is very difficult to analyze where we obtain your minimum solution, at which step we obtained it. So these are the some of the difficulties we faced when you are using your Boolean algebra. So in order to avoid that, so we were going to use the Karnaugh map method. So in a short form, we're going to call this as a K-map method. So what is a K-map method is, it is as similar as that of your truth table. So a truth table which is defined with a set of inputs and their outputs, so which are represented in the form of your columns as well as your rows. The same manner here also in your K-map, you have an array of cells where in each cell we can represent the binary values of your input variables. And now the K-map, it feels that it was very difficult to use your Boolean algebra laws, rules and theorems for simplifying your logical functions and to get your minimal expression. So we were moving to the K-map method, so which is a systematic method of simplifying your Boolean expressions. And after minimization or after utilization properly, so you'll get your function into a simplified SOP form or into a simplified POS expression, so that we obtain your function into a minimum number of literals. So with that minimum number of literals, we can implement your function with less number of logical gates, and the difficulty of designing your circuits will be reduced. So as well as the complexity is reduced and the cost of the circuit is also reduced with the use of your minimization. Next, we are going to prefer this K-map method only for the input variables with the 2, 3, 4 as well as with the 5 variable. Now, so a two variable function which is having a combination of 4 array or 4 cells, and a 3 variable which is defined with a 8 number of cells, a 4 variable is defined with a 16 number of cells, along with the 5 variable. So here the 5 variable is represented on using 32 number of cells. So now this how we are representing and what are the indexes of your each row and each column. So which code we are going to use for indexing your columns and rows, that we are going to learn now. So as you observe here, so it's a two variable K-map. So here if you have two variable K-map, we can substitute on your given variable the possible zeros and ones are 4 combinations, so which are 0 0 0 1 1 0 1 1. And in order to differentiate these all the 4 cells, we represented their decimal codes in the at the every corner of your cells of your K-map. Next, let me map your function. So using your K-map method, how to map your function is, so a K-map or a function is mapped using your K-map method. So by placing their corresponding functional values. So your functional values in binary, it might be a 0 or it might be a 1. So now based on your function, so for the 4 possible minterms or your 4 possible maximum, you could place your functional values in those corresponding cells. That is called as a mapping method. So mapping is nothing but placing the functional values onto the corresponding cells of your each K-map, or the cell of your cell of your K-map is called as a mapping technique. So in a 3 variable K-map, now when we observe this, so it is having total number of cells. So it is a square which is subdivided into 8 number of cells. So here we have 2 rows and with the 4 columns. Now these 2 rows indexes are represented with the possible A value with 0 and A value is 1. So where BC are the lower significant variables. So this must be represented on the above axis, and your most significant variables are represented in the below axis. Now, first row index is started with 0, 0. Second row index is 0, 1. Third row index is started with your 1, 1. And the fourth row index is 1, 0. As here, if you observe carefully the sequence of your index of column, so it represent the gray code sequence. So this 0, 0 is the decimal code of your 0, 0, 1 is the decimal code of your 1. So 1, 1 represent the gray code of your column number 2. 1, 0 is the representation of your gray code for a given third column. Okay, so now we are going to use the gray code for indexing your rows and columns here. Now for a 4 variable K map, this big square is subdivided into a 16 number of cells. So now in order to do that, so we are going to use 4 number of rows and with a 4 number of columns. So here also we represented the row index with the gray code. So started with 0, 0, 0, 1, 1, 1, 1, 0, and column indexes are also labeled as 0, 0, 0, 1, 1, 1, 1, 0. And now we wrote the decimal codes of each cells. So here it is 0, 1, 3, 2 by including your AB 0, 0, here 1, 0. The decimal code is 2, 0, 1, 0, 0 is 4, 0, 1, 0, 1 is 5, 0, 1, 1 is 7, 0, 1, 1, 0 is 6. So next 1, 1, 0, 0 is 12, 1, 1, 0, 1 is 13, 1, 1, 1, 1 is 15, 1, 1, 1, 0 is 14, 1, 0, 0 is 8, 1, 0, 0, 1 is 9, 1, 0, 1 is 11, 1, 0, 1, 0 in decimal code is equal to 10. So now, so these are in this 16 cells, you can map your either the max term values or you can also map your min term values. So now a 5 variable K map is implemented by using two 4 variable K maps where each 4 variable is having 16 cells. So then we can substitute that 32 combinations of your input variables on this 32 number of cells. So now, so it is formed as a 2 layer. So the first layer or the topmost layer will have your A value 0. The bottommost layer is having A value is equal to 1. So this total cells are having the value of A is equal to 1, and the first layer is having the value of A equal to 0, and here the row indexes of BC is started with 0, 0, and now next second row index is 0, 1, third row index is 1, 1, fourth row index is 1, 0. Column indexes are of DE is 0, 0, 0, 1, second column, 1, 1 is the index of your third column, 1, 0. Now, if I included that all the 5 variables with this possible zeros, so then I could map your maximum of 0 or minterm of 0 onto the first cell which is designated with the decimal code in the corners as 0. So 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15 and 14. The below layer you could have your cells which are designated with 16 to 31. So like this, so we can map your function on your K variable, and using the method of adjacency, we are going to minimize your function into minimum literals or in the form of simplified SOP form or in the form of your simplified POS form. So here are the simple steps we are going to follow for minimizing or solving your expression using K-map method. So first step is select a K-map according to the total number of variables. So if your function is represented with your 2 variable, you need to prefer the 2 variable K-map, and it doesn't prefer the higher order variables which are 3 or 4 and 5 is not suitable. Now if your function is a, for example, if your function is a 3 variable, you should not prefer either a 2 variable or your 4 or 5 variable. You should prefer only the 3 variable K-map. So based on your number of variables, choose your K-map, so which is of 2 variable or a 3 variable or a 4 or 5 variable. Next, identify your given function. So your given function, is it in the form of standard SOP or it is in the form of standard POS? If it is in the form of your standard POS, you could have your max term has to be mapped onto the K map. If your function is given in the terms of your sum of minterm, you should place your minterms onto the corresponding cells. So now for standard SOP, so you need to take the minterm functional values which are 1 onto the blocks of your each K map. We have to put those logical ones onto the corresponding cells. Next, if your function is in POS form, so then the functional value of maxterm is 0. So those zeros must be placed on the blocks of your K map with respect to your maxterm cells. This next step is, so now we need to go for the use of your adjacency. So what does mean by this adjacency is forming into a big square is called as a adjacency. It will follow the power of 2. So you could form 2 power 1 which is 2 square adjacency. You can form 2 power 2 is 4 square adjacency. You can form 2 cube which is 8 square adjacency. So and trying to that cover your as many as number of your elements, you can cover it into a single group. So which could give you, each group could give you the minimal expression from each group. After upon forming into your groups, so we have to repeat this procedure in order to find your product terms. So till you cover your all the minterms or your maxterms, so we have to group these all the elements, then we could obtain your from each group. So those we are considering it as a product term, and we have to add those, or we have to sum all those things, all the product terms, in order to form your simplified SOP form. The same manner, if your function is in POS, standard POS, upon mapping your functional values, we have to check for your big square, or we have to check for your more elements to be covered into the single group. So and we have to check here every element should be covered into a one of the big square. So then upon covering all the max terms, then from each group of your square we have your sum terms, and those sum terms must be multiplied in order to obtain your simplified POS form. Upon getting this simplified SOP form or your simplified POS form, next step is we have to implement your minimized Boolean function using your specific gates. If they ask you to design using only and or invert gates, you have to prefer the AOA logic. If they ask you to design your circuit using your universal gates, you have to prefer your universal gates which are NAND and NOR gates. Now this is the way of your mapping your function of two variable onto your KMAP. So this is the example function we have taken with the two input variables of A, B, and with the functional values, one function which is having 0, 0 for the minterm of 0, 0, and the remaining minterms are having a functional values of 1. So now when you are mapping of a total function, so just place your functional values into their corresponding cell based on your input variables. As here A, B are 0, 0, your functional value is 0. So we have placed in that corresponding cell with a 0. Next 0, 1 is 1 and 1, 0 is 1, 1, 0, 1, 1 is also 1. So in the same manner, so 3 variable function with the inputs of A, B, C with the functional values I have here, and we map all these functional values into their corresponding cells. So 0 decimal code is 1, so 1, so which is ABC is 0, 0, 1, the function value is 0. Next 2 is 1, so we have placed here. Next 3 is also 1, so we placed here. 4 is 1, so 5 is 1, 6 is 0, 7 is 0, 6 is 0, 7 is 0. The same manner for a 4 variable K-map also, we placed here functional values with the 4 variable input variables which are A, B, C, D and their functional value. This is called as a mapping your function or representation of function using your K-map. Now a 5 variable K-map we have taken here, and now for this 5 variable K-map, for the decimal code of 5, 8, 15, 24, 31, the functional values are 1 and the remaining all are zeros. Hence we place the functional values are 1s on those corresponding cells of 5, 8, 15, 21, 24, 31, and the remaining cells are having the functional values are 0. So we have placed your, or we put your zeros into their corresponding. So this represents the mapping of your given function onto your K-map. And in the next class we are going to see that how to minimize your function using your K-map method. What are the rules, that all the things we are going to cover in the next session. Thank you.